Types of waves. Waves can be classified based on the direction in which the particles of the medium vibrate compared with the direction in which the waves move. Two main types of waves are transverse waves and compressional, otherwise known as longitudinal waves. A transverse wave and a compressional wave can combine to form another kind of wave called a surface wave. With transverse waves, the particles vibrate in an up and down motion. Watch the wave move across the screen by following the blue line at the top of each crest. That shows how the energy of the wave is moving from left to right. But if you follow the red squares, you can see that the particles of the medium are just going in up and down motion. They are not going along with the wave. Transverse means moving across, because the particles move perpendicularly to the direction of the wave's motion. Highest point on a transverse wave is the crest. Lowest point on a transverse wave is the trough. Trough rhymes with cough. The animal feeding trough below has the same shape as a wave trough. Longitudinal waves. Particles of the medium vibrate back and forth in the direction of the wave motion. The parts of the wave where the particles are crowded together are known as compressions, whereas the parts of the wave where the particles are spread apart are known as rarefactions, because the particles are rare in those areas, rarefied. Compressions and rarefactions on a longitudinal wave are comparable to the crests and troughs on a transverse wave. You can see in the illustration that the compressions are like the crests on a transverse wave, and the rarefactions are the comparison to the troughs on the transverse wave. Sound waves. Sound waves are longitudinal waves and travel through the compressions and rarefactions of air particles. If you've ever seen a speaker cone, you see it moving in and out as it's playing music. Where the speaker cone is moving outward, it compresses the particles into a smaller area. When it's pulling back, it pulls the particles apart, leaving a rarefaction. And that repeated rarefaction and compression pattern will give you the sound that you hear. Third type of wave is the combination or surface waves. Waves that form at the boundary of a medium can become a combination of transverse and longitudinal waves. It's called a surface wave. Ocean waves are this type of wave. Look at the blue dots. You see that the blue dots are moving up and down, but they're also going a little bit to the right and left, forming a circular motion. And the particles get closer in spots and farther apart in spots. Just looking at it overall, it looks like a transverse wave, but when you look at the blue dots, you can see how it becomes partially compressional in nature as the particles get closer and farther apart. So think of ocean waves and a buoy floating on the water. Combination waves or surface waves form between two different media, in this case the boundary between water and air. So watch the buoy trace a circular path against the sky. So that shows how objects floating in the ocean are going to create a combination pattern where it's moving somewhat like a transverse wave and somewhat like a compressional wave.